keep me up all night. Gotta make a move on that.
Hey, have you heard about petroleum engineering?
Petroleum engineering? Yes, I have heard about it, but I don't really know what it is about. I suppose we can ask our friends from that department to explain to us what it really is.
Petroleum engineering is a branch of engineering that focuses on producing and obtaining crude oil and natural gas. Specifically, this field deals with the production, refinement, and regulation of hydrocarbons for worldwide use. Due to the wide expanse of responsibilities, petroleum engineering involves expertise from chemistry, geology, and geophysics. The advantages of petroleum engineering are profound because petroleum serves as an important energy source.
Petroleum engineering is a field of engineering concerned with activities related to the production of hydrocarbons, which can be either crude oil or natural gas. Exploration and production are deemed to fall in the upstream sector of the oil and gas industry. Exploration by earth scientists and petroleum engineering are the oil and gas industry's two main subsurface disciplines, which focus on maximizing economic recovery of hydrocarbons from subsurface reservoirs. Petroleum geology and geophysics focus on the provision of a static description of the hydrocarbon reservoir rock, which petroleum engineering focuses on estimation of the recoverable volume of this resource using a detailed understanding of the physical behavior of oil, water, and gas within porous rock at very high pressure.
The combined efforts of geologists and petroleum engineering throughout the life of a hydrocarbon accumulation determine the way in which a reservoir is developed and depleted, and usually they have the highest impact on field economics. Petroleum engineering requires a good knowledge of many other related disciplines such as geophysics, petroleum geology, formation evaluation, drilling, economics, reservoir simulation, reservoir engineering, well engineering, artificial lift system, completions, and oil and gas facilities engineering.
Geologists and geophysicists have agreed on the existence of a prospect, a potential field. In order to find out if hydrocarbons are indeed trapped in the reservoir rock, we must drill to hit them. Bearing in mind the knowledge acquired about the substratum and the topography of the land, the best position for the installation of the drilling equipment is determined. Generally, it is vertically above the point of maximum thickness of the geological layer suspected of containing hydrocarbons. The drillers then make a hole in conditions that are sometimes difficult. Of small diameter, from 20 to 50 centimeters, this hole will generally go down to a depth of between 2,000 and 4,000 meters. Exceptionally, certain wells exceed 6,000 meters. One of them has even exceeded 11,000 meters. Certain fields can be buried at a depth equivalent to the height of 12 Eiffel Towers. The derrick is the visible part of the drilling rig. It's a metal tower several tens of meters high. It's used to vertically introduce the drill strings down the hole. These drill strings are made up of metallic tubes screwed end to end. They transmit a rotating movement, rotary drilling, to the drilling tool, the drill bit, and help circulate a liquid called mud, because of its appearance, down to the bottom of the well. The drilling rig works like an enormous electric hand drill, of which the derrick would be the body, the drill strings, the drive, and the drilling tool, the drill bit. The most usual tool is an assembly of 3 cones, from which comes the name tricone, in very hard steel, which crushes the rock. Sometimes, when the rock being drilled is very resistant, a single block tool encrusted with diamonds is used. This wears down the rock by abrasion. Through the drill pipes, at the extremity of which the drill bit rotates, a special mud is injected, which the mud engineer prepares and controls. This mud cools the drill bit and consolidates the sides of the borehole. Moreover, it avoids a gushing of oil, gas or water from the layer being drilled by equilibrating the pressure. Finally, the mud cleans the bottom of the well. As it makes its way along the pipes, it carries the rock fragments, cuttings, to the surface. The geologist examines these cuttings to discover the characteristics of the rocks being drilled and to detect eventual shows of hydrocarbons. The cuttings, fragments of rock crushed by the drill bit, are brought back up to the surface by the mud. To obtain information on the characteristics of the rock being drilled, a core sample is taken. The drill bit is replaced by a hollow tool called a core sampler, which extracts a cylindrical sample of several meters of rock. This core supplies data on the nature of the rock, the inclination of the layers, the structure, permeability, porosity, fluid content, and the fossils present. After having drilled a few hundred meters, the explorers and drillers undertake measurements called loggings down the hole by lowering electronic tools into the well to measure the physical parameters of the rock being drilled. These measures validate or invalidate or make more precise the hypotheses put forward earlier about the rocks and the fluids that they contain. The log engineer is responsible for the analysis of the results of the various loggings. The sides of the well are then reinforced by steel tubes screwed end to end. These tubes, called casings, are cemented into the ground. They isolate the various layers encountered. When hydrocarbons are found, and if the pressure is sufficient to allow them to come to the surface naturally, the drillers do a flow check. The oil is allowed to come to the surface during several hours or several days through a calibrated hole. The quantity recovered is measured, as are the changes in pressure at the bottom of the well. In this way, a little more knowledge is gained about the probable productivity of the field. If the field seems promising, the exploration team ends the first discovery well and goes on to drill a second, even several others, several hundred or thousand meters further away. In this way, the exploration team is able to refine its knowledge about the characteristics of the field. The decision to stop drilling is made only when all these appraisal wells have provided sufficient information either to give up the exploration or to envisage future production.
The last stage of the petroleum industry is refining. Petroleum essentially is useless in its natural state. What's valuable and useful are the various components that make it up. These components all have different molecular weights and therefore have different boiling points. Petroleum companies take advantage of these different boiling points and use them in order to separate the different components. In order to do this, the petroleum is first heated to temperatures as high as 600 degrees Celsius by pumping it through a furnace. The resulting petroleum gas is then piped into what is known as a fractioning tower, or distillation column. As the gas rises up through the tower, different components condense at different heights. A series of bubble caps then prevent the oil from falling down once it condenses. The petroleum is then pumped out through pipes for further refining, such as the removal of sulfur in desulfurization units. Sometimes the heavier elements of petroleum are broken down into lighter, more useful components, using a coker or hydrocracker. The major products resulting from petroleum refining are liquid petroleum gas, gasoline, naphtha, kerosene, diesel fuels, fuel oils, lubricating oils, paraffin wax, bitumen, and petroleum coke. These products are then used in our everyday lives, such as powering our cars.
According to the U.S. Bureau of Labor Statistics, petroleum engineers reported an average salary of $138,980 per year in 2011, significantly higher than every other type of engineer. Petroleum engineers who work for oil and gas extraction companies reported an even higher average salary, $150,000 per year, and the highest paid 25% of petroleum engineers in the United States reported salaries of $172,040 or more per year. Few jobs requiring only a bachelor's degree have
Very favorable employment prospects are another advantage of preparing for a career in petroleum engineering. While the projected rate of job growth in this field between 2010 and 2020 is just 17%, slightly higher than the 14% growth rate expected for the American economy as a whole. The Bureau of Labor Statistics predicts that many openings will occur throughout the decade as current workers retire. In addition to the petroleum extraction industry, petroleum engineers are also find work in the mining and petroleum manufacturing industries. Keep in mind, however, that finding work in this profession may require relocation.
One of the petroleum engineering's greatest advantages lies in maximizing the amount of oil and gas obtained. Using geology, mathematics, and physics, these engineers must understand the nature of oil and reservoir rock. Petroleum engineering optimizes oil product through proper well placement, regulating production levels, and using state-of-the-art oil recovery techniques. Much of this reservoir analysis is accomplished through sophisticated computer modeling to predict the best location for the well site, as well as proper drilling technique.